In this video, we're going to review how to analyze your spreadsheet data for the purpose of writing a possible errors paragraph. So we're going to use the Apple Lab data in order to practice writing a possible errors paragraph. So first thing we're going to do is we're going to look for some outliers. So outliers are going to be any numbers that stick out as being pretty different from the average. So if you look at the left side of the screen, we have 9 different measurements for the Apple mass, and then our average mass is 158.54 grams. So we want to look at trials 1 through 9. So we want to look at these and compare to the average to see, are there any values that stick out as being pretty different? And if there are, then those are going to be our outliers. And if we look at this, we actually have a couple values that we can include as outliers. So for example, in trial 1, we have 125.18 grams. We have 127.76 grams. That also looks like an outlier. 118.8 grams. And then if we jump further down to trial 6, we have 116.1 grams. And if you look at trial 8 with 359.5 grams, that's a very large number, significantly different from our average. So that definitely counts as an outlier. There's a couple other values in these trials that you can argue are outliers. For right now, we're just going to have these 5 values to discuss, but technically you could make an argument that more of these values would be an outlier. Next thing we're going to do is we're going to compare our actual or theoretical Apple mass and then our average Apple mass and see if we can find anything there. So our theoretical is 85 grams, and then our average is 158.54 grams. So if we compare these two numbers, 85 and 158.54, they're both pretty different from each other. So they're far from each other. Next, we're going to look at our percent error and percent RSD. So I'm going to write our percent error, 86.51%, and our percent RSD, which is 48.34%. I'll close this out. So looking at those two values, our percent error is pretty high. If it was below 5%, then this would mean it's accurate, but it's above. So this is not accurate. If we look at our percent RSD, it's 48.34%. If it was below 2%, it would be precise, but this is way above that. So this is not precise. All right, so next we're going to move on to these guiding questions, which we kind of already answered. We already looked at our data and we determined that no, it's not accurate, and no, it's not precise. And how do we know? It's because we're comparing it to the 5 and the 2. So our percent error is above 5%, so that means it's not accurate. And since our percent RSD is above 2%, that means it's not precise. If it was below, then they would be accurate and precise. Now that we've kind of done a little bit of analyzing our data, the next thing we're going to do is now we're going to put this together and start writing out our possible errors paragraph. And what we're going to be using as a guide are how to write a possible errors ERC, which breaks down what goes in each section and also has some sentence starters here. We're also going to be using this sample or samples as a reference so that we know what to include and what to avoid. And more specifically, we want to be using this as our guide for our writing. This is going to help us make sure that we include everything that is needed in order to have a well-written possible errors paragraph. This, how to calculate average percent error and percent RSD, is also helpful because on this sheet, it actually tells you which each of these values means. So our percent error is telling us about accuracy, how close our average is from the correct or theoretical, and it should be under 5% in order to be a good result. And our percent RSD measures precision. So this is telling us how close our data points are to each other. And under 2% is considered good. percent RSD tells us about the reliability of our data, and percent error tells us whether our data is valid. So that will be referring to as we move through this. So first, we're going to start with our evidence section. So in our evidence section, we want to make sure we include our percent error and percent RSD. So when we're writing this, you can say the percent error is, and I'm just going to scroll up to see that value, 86.51%. The percent RSD is 48.34%. So that's all you have to include in your evidence section. We're going to add 2 more pieces of evidence in here just to help us with the next section, which is going to be the reasoning section. I'm going to add in the theoretical apple mass, and the average which is taken from our Google Sheet. The average is 158.54. All right, now we're going to move on to our reasoning section. This is where we're going to explain the accuracy and our precision of our data. So let's go back to this checklist here, because what we just did is we gave some clear evidence, so that's our percent error, our percent RSD, and we kind of went one step above that and included our theoretical and our average. That's going to help us for these next section, which is going to be the reasoning section. So now what we're going to look at is explain the accuracy of the data by comparing to the target value and using percent error. So that means we're going to compare our average and our theoretical and explain what that tells us about the accuracy of our data. So that's what we're going to move on to next. So the theoretical apple mass, now I'm going to put the value in parentheses, and the average apple mass which is 154 or 158.54. Those numbers are pretty far away from each other. So they're far apart. This means, so the further our average and our theoretical are, the less accurate our data is. The closer those 2 numbers are, so the closer you're in the bullseye of the target, the higher your accuracy. So this means that our data is not accurate. And then we can say our percent error is above 5%. So by writing this out, we successfully explain the accuracy of the data by comparing to the target value, which is the theoretical. And we also used our percent error to explain why that data is not accurate. Now what we're going to do is we're going to move on to the next one. Explain the precision of the data by discussing our percent RSD and discussing outliers. So let's go back here. We definitely have outliers. We have a lot of outliers. So we are going to talk about this next. We have the following outliers. We have from our data 125.18 grams, 127.76 grams, 118.8 grams, 116.1 grams, 359.5 grams as some outliers. So this is showing how spread out our data is. This shows that our data is spread out. And what this means is that our data is not precise. The more spread out your data is, the less precise it is. The closer your data is to each other and closer to the average, the more precise your data is. So this shows that our data is spread out. This means our data is not precise, and our percent RSD is above 2%, because our percent RSD was 48.34%, which is way higher than 2%. So if we look at this, we just completed this next item on our checklist where it says explain the precision of the data by discussing the percent RSD. We did that and discuss outliers if there are any. So now we're going to move on to the next one. Explain what may have caused outliers or inaccurate or imprecise data. So now we're going to refer to this chart here. So we use this chart if our percent error is above 5%. That means we have some accuracy errors. So you must talk about accuracy errors. If your percent RSD is over 2%, then you must discuss precision errors. What you want to avoid is this section right here, the not acceptable side, which are our human errors. So if you have your percent error and your percent RSD both over what they should be, you must talk about each. If only your percent RSD is over 2%, but your percent error is okay, meaning it's under 5, then you just have to talk about precision errors and you wouldn't have to mention any accuracy errors. So this is just to help in your thinking, like what do I need to discuss in this section? So since both of our data is not precise, it's not accurate, we must talk about both types of errors. So as a guide, we're going to use this sentence starters. The following sources of error may have affected our results. So let's start with that. So the following sources of error may have affected our results. And this is when we would start to think about, okay, what happened in this Apple lab that could have resulted in this precision and accuracy, those values being so high. So if you think about the lab, we had different scholars that were carrying out the procedures, because we had a couple scholars from each table group carrying out the procedure, meaning they were measuring the mass of those apples, and it was not the same scholar every single time. So that's one reason why that percent RSD is so high. If you think about in terms of the accuracy errors, the tools that you used, for example, the majority of the scholars use the tabletop balance, which does not have a high degree of accuracy, versus using something like the analytical balance. The other thing you can think about are the samples that we use, the apples. If you think about the apples, not all the apples look the same. One apple was a significantly larger apple compared to the other apples. They were a lot smaller. So the samples we used were not the same. The other thing you want to think about is how do we know, or do we know, if those apples came from the same source? Did they come from the same store? Are they even the same type of apple? You don't know because I just provided you those apples. So all of those things would be good things to mention. What we want to avoid are things like, oh, we did not know how to use the tabletop balance. We did not know how to use the analytical balance. We measured the apple mass wrong. We did not follow the steps correctly. My lab partner messed up the measurements for the apple, etc., etc. Any human errors you want to avoid. So let's start by including some accuracy errors in our possible errors paragraph. So, for example, the following sources of error may have affected our results. We can say the tabletop balance does not have a high degree of accuracy. We can also talk about our samples. The samples, and by samples we can be more specific. The apples we used were not all the same. So both of those two would be examples of accuracy errors. This would explain why that percent error is so high. Now let's explain why that precision, our percent RSD, is so high. So we can say, for example, different scholars carried out the procedures. And when you're writing these, the possible errors, you just need to include at least one. For example, if your percent error is too high, include just one accuracy error. If your percent RSD is too high, include just one precision error. If you want to add more, you can. The more detailed you are in this, the higher your grade. The less detailed, the lower your grade would be. Now let's wrap this up by writing our claim. So our claim is going to state whether or not our data is valid and reliable, which is right here. And we're going to use this sentence starter to help us with writing the claim. So let's start by writing based on the accuracy and precision of the data. We believe our results are reliable or unreliable. Okay, so if our data is reliable, this is talking about how close our trials are to each other. So that means our percent RSD should be under 2% if our data is reliable. But if you look at our data, our percent RSD is way above 2%, which means our data is not reliable. So we can say we believe our results are, and we're going to say out of these two options, we're going to say unreliable. And then we have to decide, okay, based off our results, is our data valid or invalid? So valid, this is how close your data is to the theoretical value. That means our percent error should be under 5%. If it is, that means our data is valid. If it's not, that means our data is invalid. And if we look at our data, our percent error is way above 5%. So that means that our data is also invalid. So this means since our data is unreliable and invalid, we cannot use this data to make a claim. We can only use our data to make a claim if two things are true. If our data is both reliable and valid, meaning our percent RSD is under 2% and our percent error is under 5%, then that means we can definitely use our data to make a claim. But if even one of these is over what it should be, then we cannot use that data. It is invalid or unreliable. If it's either one, we cannot use our data. So for ours, both of these things are true. It's unreliable and it's invalid. So we can definitely not use this data to make a claim. If they were both good, meaning it was reliable and valid, we can use it to make a claim. So this wraps up how to write a possible errors paragraph. Good luck on your performance task.